All right, so we've been talking about exponential expressions, and today we're going to be doing exponential equations. So whenever you have an equation like this, you want to recognize if it's exponential or not. And an exponential equation is always going to have some base, let's call it b, and it's being raised to some power, and it's going to be equal to something, right? Well, what we want to do is we want to solve for x. We want to solve for the variable x, or sometimes we want to solve for y. So the first step that we have to do is isolate the variable. We have to make sure that we can get x by itself. So for this first one, I have 2 raised to the x power. What I need to do is I need to get x by itself. I need to make sure that I can get this x by itself and get rid of the 2 that it's underneath. Well, how do I do that? Well, I'm going to do the opposite of an exponential expression. I'm going to do a logarithmic expression. And this logarithmic expression is going to have whatever base you started off with. So if you started off with a base of 2, for example, for this one, you would just have a logarithm with a base of 2. And you would be doing this to both sides of the equation. So I have to take the logarithm base 2 of 2 to the x power. That's the left side of the equation. And then I have to take the same logarithm of the right side. So I'm going to have log base 2 of 32. Log base 2 of 32. So what I'm doing is I'm taking the logarithm of both sides. So that way the x can be by itself. What's going to happen is this base of 2 and this base of 2 are going to cancel each other out. And then whatever's left in the exponent is going to come down. So the x is going to come down on the left side, and then on the right side, I have something that I can work out. So what's the logarithm base 2 of 32? That would just be 5, right? So x would be equal to 5. But how did I know that? The logarithm base is what's going to be the base of the exponential expression. And then whatever exponent I need to raise 2 to the 32 power, that's going to be that number. And that number in this case is going to be a 5. So once I have my answer, I can put it inside of a solution set. So now step 2 is done. The last step I have to do is step 3, which is to check my answer. So I'm going to do that on the right side. So when I check my equation, I always start off with my original. I have 2 raised to the x power is equal to 32. What I'm going to do is I'm going to take my answer that I got and put it in place of the x. So I get 2 raised to the 5th power is equal to 32, and 2 raised to the 5th power is 32. So essentially, I get 32 is equal to 32, and that's my true statement. So once I got the true, I know that 5 belongs inside of the solution set. Let's try number 2 now. This time the base is 3, and the exponent is x plus 1. Well, we can get that x plus 1 by itself, but to do that, we would have to take the logarithm of both sides. So I'm going to take the logarithm of base 3 of the left side, and I'm going to take the logarithm base 3 of the other side. So now I'm taking the logarithm with a base 3 of an exponential function with base 3. So that's going to cancel the 3's out, and the x plus 1 is going to come down. On the other side, I've got logarithm base 3 of 27. That's going to be 3. So this is what's asking, if you have a base 3, what exponent do you need to make it equal to 27? And this time it would be 3 raised to the 3 power. So I've got x plus 1 equals 3. The last thing I have to do to get x by itself is to subtract 1 on both sides. So doing it over here, if I subtract 1 from both sides, then you're going to get x is equal to 2. So that's what goes inside my solution set. Positive 2. So that's my answer for that one. I know that if I plug in 2 for x, it'll work, because when I check it, I'm going to get 3 raised to the 3 power. So I start off with my original equation. I plug in 2 for x, and I get 2 plus 1. 2 plus 1 is going to give me 3. So then that works. I get 27 is equal to 27. So that's how you solve an exponential equation. You're basically just taking the logarithm of both sides, and then you get x by itself.